Darren Bailey here with the Irish Farmers Journal. I'm standing in the JCB World HQ here in the UK. I'm joined by Julian Carter and we're going to have a look at basically the birth of the backhoe in what is the birthplace of the backhoe. Am I right, Julian?
That's correct, yes it is. This is where it all started.
And is it fair to say the JCB 3CX is a very iconic machine in Ireland, and is it safe to say that it was basically the backhoe that put JCB on the map?
It is, and it's how a lot of companies started. They started with backhoe loaders. They built their businesses from there, from a single machine to a fleet to all types of machines they have today. Yeah. It all started after the war, really, when there was a need in the UK and most of Europe for rebuilding and infrastructure work. Machines at that time were quite primitive and quite dedicated. They had bulldozers, you had rope excavators and loading shovels as well, but hydraulics was still in their infancy. So there's a need for a highly versatile machine which didn't need large low loaders to move them around. Okay. JCB at that time in the late 1940s and early 1950s were developing a range of agricultural loaders. And it's on a sales trip Mr. Bamford went to Norway. He actually spotted a tow-behind backhoe, a small excavator, and that really caught his eye and thought he could do something with it. So he bought that design, bought that machine, brought it back here to the factory, and him and his engineering team looked at it and thought how they could actually make it better. But the iconic moment really was when Mr. JCB thought about putting the backhoe on a tractor along with the front end loader, and designed it specifically for industrial use. That was a sort of key moment which sort of set up JCB for the future.
What was the next step?
It was how it could be made more efficient, how it can be made more productive, and also trying to make it versatile to sell into different applications. And JCB, Mr. JCB was a great marketeer, and he could see there was opportunities in different sectors, you know, for the civil engineer, for utilities, for local authorities as well. So they designed and developed a range of attachments to go on the front and the back of the machine. So it became the Swiss Army knife.
It added to the versatility of the machine.
That's right, so it could work in different applications.
But am I right in saying, Julian, that machine was a purpose-built machine? It wasn't built onto a Fordson major tractor?
No, they all started on a tractor, so other competitors as well were developing similar machines as to a JCB around what was a popular Fordson major tractor and Nuffield tractors at the time.
Okay.
The limitations with the tractor was with the amount of stresses going through the structure. So JCB developed the Hyder chassis, which allowed the stresses to be taken on the structures and not so much the tractor. And then it evolved in making it more of a purposeful design rather than just based on a tractor.
So when did the actual purpose-built, we'll call it, backhoe come into production?
That was with the JCB 3. Which we have here behind us, and that was where JCB created the first side shift backhoe, which enabled the excavator on the rear to be slid left or right to allow it to dig parallel to buildings and trenches. And it had the Hyder chassis on the machine, so it took the stresses away from the tractor units and put it through the structures and the chassis. So in 1961 the JCB 3 came out, and Mr. JCB saw an opportunity for both larger and also smaller machines. So he developed then the JCB 4, which is a bigger, more powerful machine for like a civil engineers, for road construction. But also there's a need for the small builder for a smaller machine, which is quite nimble for doing smaller, shallower trenches and work in landscaping and also in cemeteries as well.
Yeah.
So the JCB 1 became known as the grave digger to many people.
What was the next major turning point in the development of what is now the modern backhoe?
So we invested in quieter cabs, more luxurious cabs, and we even had the option of a kettle back in the 1960s for the operator to make a brew in the machine. So quieter, more comfortable, luxury seats, and even air conditioning was an option back in the 1960s. But it's also making the machines more efficient, making them stronger, and greater output as well. And that's when the turning point came in 1980, when JCB, after about 10 years of investment, launched the 3CX, which came with an option of four-wheel drive as well.
I suppose when the 3CX came out, it would have gained a lot of market share by being such a popular machine, and then again offering four-wheel drive was obviously a huge plus for off-road work, which is what primarily it's designed for.
That's right. I mean, up until then it'd be based on tractor configurations, which were at that time two-wheel drive, and many competitors thought there would never be a need or demand for four-wheel drive. and JCB developed the four-wheel drive back in 1980, and we had extending dippers on there to give the operator further reach and dig depth, and to avoid repositioning machines so often. Coupled with four-wheel drive and the greater power we had on that machine, it really was a turning point in JCB, and that's what grew our market share throughout the world.
Is there any design features as such even that have carried through to the modern machine?
Yes, I mean the fundamentals of the machine with a front-end loader and an excavator on the back are still primarily the same, but what has been refined is the efficiency of the machine and the performance of the machine over the years, and of course it's got a lot more quieter cabs, more comfort creatures, but still there's still features on the machine from the 1970s which are identical to today. For example, the actual bucket movement on the rear of the arm, the excavator, that's identical geometry on the bucket as it was back in 1977. So there were some things we got right back in those days we haven't actually changed throughout the years.
I'm joined here with Liam Brown, Managing Director of Backhoe. Liam, tell us a little bit about this new backhoe.
Yeah, in terms of the backhoe, we've also got, it's not just one single platform. We have now effectively 5 major platforms in the backhoe family, ranging from a 1CX all the way through to the 5CX. So, you know, the opportunities and the sectors that we feed into and from our customer base is quite immense. Just to give you some ideas on that, you know, we launched our very versatile 3CX compact last year, and the real reasons behind that is that, you know, house building is changing, sites are becoming more compact, roading is becoming more challenging, and therefore a smaller product and more versatile needed to be designed. We've got a 5.7 metre turning circle on that. It's a smaller machine and very versatile in terms of capabilities with attachments. We can do pothole repairing, we can do road repairs, we can do the standard excavator work that the current backhoe does today. So it isn't all about having a one-size-fits-all. Literally, it isn't. What we are doing, and we need to, is excite the market with different sectors.
I suppose emissions are a big thing. I mean, we're on Tier 4 final now at the moment.
Yeah.
The engine that you're fitting to your backhoes is all JCB's own engine?
Yeah, across the platform we have a number of engine variants, and the reason for that is economic viability, availability of engines. So on our major 3CX, 4CX, 5CX, they're JCB engines. On our 1CX we are using Perkins engines in there because of the platform, and on our 3CX compact we're using the Kohler engine. So there is quite a broad brush, and at some stage of course we're always considering the viability of using all JCB product, but fundamentally the complexity of doing that, and also then the business case for doing that, is not always robust and the best way to do it.
I presume safety is obviously a major concern with everybody, and it's getting tighter and tighter with health and safety. I mean, what has JCB employed on the backhoe to make it safer?
Well, again, examples are ease of use in many cases. What we also try to do in terms of user-operator, user interface, when you look at that, simplicity, helps. The less amount of operations to start the machine, to move the machine. All of that is adding to the driver being more focused. Innovation still remains the lifeblood of the business, and that's what we pride ourselves in. And I think on previous launches over the last years, you can see that we're still driving for that. 3CX compact almost only 12 months ago. The Hydro Dig only just been launched last year, again all on innovation. So there's a high amount of investment in terms of the business constantly. There are over the circa of 100 programs that we're working on at any one time, whether that's covering legislation requirements, whether that's covering health and safety requirements, or indeed whether that's creating a brand new product to be more innovative in the market. Okay, this is the start of the process, fundamentally where we cut all of the material for the fabrications. To give you an overall view of that, in the business we use over 250 tons of material every week, ranging from 6mm to 20mm in thickness of steel. So this is the start of the process, typically where we'll do our laser cutting and profiling. And effectively then we'll do our forming on some of our press work here, where we would form the material ready for sub-assembly into the welding jigs and fixtures. After it's gone into the welding jigs and fixtures, in terms of the process, then we would move all that material into our shot blast area, which is a key preparation area for our substrates to be painted. it goes through the shot blast, and then we start our paint process. We have 2 paint facilities here, which then paints all of our internal chassis and all of our fabrication work. After that then, they then go into the sub-assembly areas, ready then for the materials team to start building the machine, which we'll talk about shortly. Okay, so this material here, once it's now been cut, it goes on to some of our robotic welders. Many of those you can see behind us when they do the initial manual tacking, but then it goes on to our robotic machines, where fundamentally a lot of the long run welds are completed. Once it's completed that stage, as I said before, it will then go be shipped down to our in-house shot blasting facility. We still have a necessity for manual welding in many cases for difficult areas. Robotic welding, when we're building up to 90 machines a day, obviously gives us a consistent, sustainable and productivity benefit by doing that. And also from an overall design integrity, the robotic weld in many cases helps us give a stronger weld, and then from a structural point of view that's very important. Much of our steel comes from India, but depending on where it is around the world and different grades, it can be pretty much a global impact. But certainly from a Tata perspective, much of our material is sourced from them, as many of the industry sources from. There are many grades of material and of course many thicknesses as well, so it depends really in terms of fitness for purpose. Behind us we see a typical jigs and fixture, as we call it here, where many of those fabricated sub-assemblies are put together. Obviously again from a volume perspective, we're not just doing one-offs, so it's very important to sustain the quality and the accuracy of the machine by using jigs and fixtures. So fundamentally the sub parts are put into the jigs and fixtures, they're tacked in place, and then they're finally welded. Once that's put in place, we know that then is repeatable and it's sustainable, and we work to a high tolerance specification in terms of jigs and fixtures. Very important in terms of the later stages when we go into sub-assembly to mitigate any issues that we might have with variability in the process. Certain elements of the process require some high quality and high tolerance machining. So these are robotic machining centres that we have behind us, and fundamentally what it's basically doing, it's mounting the parts into the machine, and then what it's doing is machining a number of those faces. And that's important because they're key areas in terms of critical to quality points in the overall process, where perhaps hinges are being mounted on for the bonnet assembly later in the process that we'll see. So therefore appreciate that needs to be a close tolerance, it needs to have a real good mating face to avoid variability and gapping on the overall machine.
I can see the stabilizer legs, I can see the frame for the front arms and the bonnet. I mean, your chassis is really starting to take shape here at this stage. What happens here?
Okay, as you say, it is really starting to take shape, and the important piece of this now is that I spoke earlier about robotic welding. The pre-processes have all been about tacking, getting access via manual welding that the robot can't get access to. But really now, this now goes on to the main robotic welding, particularly for the long runs, where it's actually now completed by the robot. After this, then it's now ready, all the weld is complete, and it's ready then to go into the shot blast pre-paint.
So once your main frames finish this process, they are essentially completed just for finishing with shot blasting.
Absolutely. Ready then to go into the pre-paint facility.
Liam, behind me I can see the chassis are strung up here. They're heading towards this big machine. What's happening behind us?
Okay, again, the next stage in the process, we've gone through now all the sub-assemblies, we've gone through the main tacking, we've gone through now the robotic welding. After that stage now, it's all about preparation for paint. So what you see hanging behind me is a chassis going into shot blast. The shot blast effectively, as it suggests, is high penetration in terms of surface preparation. There will be, the shot blast then will automatically then cover the whole of the chassis. It will remove any surface defects. It will also then clean welds in many cases and remove any weld spatter, all in preparation then for the substrate then to be in a nice smooth situation ready for paint. After the shot blast then, it will then go into a phosphate where it will give a substrate then a complete protection in terms of preparation for 2 coats then of wet paint. 2 coats of wet paint then, which we control throughout the whole of the process to make sure it's the right thickness, has the right adhesion properties. So daily, is that we're checking that on a continual basis, just to make sure that we get the right paint adhesion and the right quality finish. So really, in summary, this process here is pre-paint.
How do you keep track of what chassis belongs to what machine and vary in different specs?
Yeah, it's a good question. I mean, daily there are operational meetings. You'll see around the facility a lot of focus on communication. You'll see team leader boards, you'll see group leaders, you'll see command centres, and indeed, I hold operational meetings on a daily basis. Fundamentally, we have customer orders which are put onto our system and manage an MIS system effectively. And what we do that will give us a build ticket. That build ticket will have a specific build specification. It will have associated barcode for it. That is then planned in for a build number, a serial number, to be sequenced throughout the whole of the facility. So any one day, start of shift through to the end of shift, there is a very clear roadmap in terms of the process of certain amount of serial numbers are going to be built that day in this sequence. What you see behind you is a kit of parts fundamentally. And what we do here is that we do sub-assemblies, and we also then create a kitting trolley with those appropriate kit of parts on. These parts will now be taken to the assembly line to rendezvous and meet up with that chassis that we've just seen blasted and painted. Again, that's all controlled by the materials and logistics team on a daily basis. It has a build ticket to a customer reference to a customer specification. So it's a very, very important area. This area here gives us a number of advantages. One is it gives us, should there be any issues with parts, both in quality or indeed in terms of availability, because we're picking it by a kit or by machine serial number, if there is a shortage or a quality issue, we immediately get some advanced information that gives us the opportunity potentially to change the sequence of that machine, should there be a shortage or should there be a quality issue. And as again, when we're building up to 90 machines a day, with so many variations and permutations, advanced warning in terms of any particular issue with material is important. Materials here, up to 4,000 parts can be used any new machine. So when the machine goes down the line, we've got to do that. There's a huge background and a huge back office that are all working on the procurement of this. And the importance of that is that those parts are coming from worldwide. So there's a huge logistics operation in terms of what you can see here, which then formulates itself into a kitting trolley.
And what's happening here, this is the first stages of assembly really, is it?
Yeah, so we've seen now the chassis been completed, they've gone into shot blast, they've gone into paint, and what these are now, the chassis now are presented to the first stage on the line, automatically to the guys, and you see that now is on a conveyor system. So really now we have a number of stations going all the way through the programme, through the facility. And what they're doing now, they're building up the sub-assemblies. This particular stage here, they'll start to put some of the hydraulic pipes in, they'll start to put some of the harnesses into the chassis. Why? Because it's easier to access here than it is when it's
when there's less components in there.
So really now we start building it up. You'll also notice here is what those kitting trolleys that we spoke about. They're on line side, they're now sequenced to that chassis by customer specification, and the guys are going to those trolleys and taking the appropriate parts off. What it's gone through now, you've seen the chassis come off, you've seen the sub-assemblies of all the way down the line. This is now then changed over onto our central line. What you'll see in place on here is the engine has been installed, the axles are now being installed, and you can see the guys now starting to hose up and put the electronics in terms of the next stages up the line. So pretty much at this stage, the engine is in place, no fluids are in place, no hydraulic oil is in place at this stage, and of course no fuel. But fundamentally the hardware of engines, axles and transmissions and the basic chassis is now ready now to go up for the final stages of those kitting trolleys to furnish it with the bonnets, with the cabs and then all the trim parts. Obviously from an engine perspective, over recent years, because of the focus on emissions and reducing emissions, obviously our engine variants are also increasing. So in terms of the challenge, it's about logistically changing over from one legislation date, which is been mandated, versus then ramping up our production accordingly and protecting our customers, and also making sure we have a smooth transition from one engine emission type to another. There's a variability in axles. Of course, you've got all-wheel steer, two-wheel steer, 3CX, 4CX. Yeah. So there's permutations on all of the main subsystems, including the cabs. So in terms of supply, obviously we have our axles supplied by JCB Transmissions, our power units from Power Systems, Cab systems provide, there's a place 20 miles away from here in terms of supply, over 35,000 cabs a year.
Is everything supplied or built by JCB?
Not everything's supplied by JCB. We have obviously a wheeled purchasing team. So in terms of, for example, HVAC systems are not JCB. We'll supply those from the experts in the field. We would have seating. We don't manufacture our own seating. We would buy those key subsystems in. Steering columns.
But the main components of the actual
main fabrications in
are
terms
all
of
controlled in-house.
The main fabrications and also the cost of the bill of material are supplied by JCB suppliers, yes.
The cab is fitted. The wheels are lining up here to go on. I mean, we're getting very near the end, I presume.
Yeah. So the process here now, as you see, you've effectively gone down one line, major chassis, transferred across then with all of the power units and transmissions put in place. And as you see behind me now, it's coming to the end of the process in terms of assembly in a way. We fit the cab, we start to fit the bonnets. The next stage is then literally then to fit the tyres. At this point here on the cab, all the connectivity to the heater systems, the HVAC systems, the electronics, ECU programming in terms of the engine management system variation, enabling the machine to be cranked in terms of engine start. All of that now is done at these stages. The only stage that's left now is after this, now it goes into fluids fill. At that stage where we're putting water, we're putting the hydraulic fluids in, and of course then the fuel. After the testing process, she will then go into the PDI, post-dispatch inspection. It's very similar to what you will do in terms of you go and buy any car. Post-dispatch inspection, it goes through one round here, and then when she's shipped to our dealers, the dealers would also go through a post-dispatch inspection.
Sun to shine. We can climb like birds soar in the sky. We can dive down deep inside. We can ride a moment through endless time. We are all born to be. Let us dream, careless and free. Let our heart lead our eyes to see the way. We can shine each day. We can beam like sky crystal blue. We can share a smile of childish truth. We can stretch our branches wild under the sun. We can flow like